Intermediate Algebra for Statistics, Using Function Notation with Linear Models, Part 2. Lesson Objective: Use data described in words to make estimates and predictions. Lesson Objective: Example 3. Sales of bagged salads increased approximately linearly from 0.9 billion in 1996 to 7 billion in 2007. Predict in which year the sales will be 11 billion. Solution: we find the slope between the points first. 7 minus 0.9 over 17 minus 6, rounded off to 2 decimal places, is 0.55. Now we find b. So we use the 0.6 and 0.9. So we have y equals mx plus b. The y in this case is 0.9 equals our slope 0.55 times our x, which is 6, plus b. We multiply. So we now have 0.9 equals 3.3 plus b. Subtract 3.3 from both sides. We have b is equal to a negative 2.4. So our equation becomes S equals 0.55 t minus 2.4. To predict when the sales will be 11 billion, we substitute 11 in for S and we solve for t. So we need to add 2.4 to both sides. This gives us 13.4 equals 0.55 t. Divide by 0.55, and t is approximately 24.36. Now, since t is the number of years since 1990, we would say the model predicts that the sales will be 11 billion in the year 2014. We can verify our work by using the graph and calculator table. So we put the equation in the y equals, and then we hit second graph, which is table. So when x is 24.36, y is about 11. Example 4. A company believes that there is a linear relationship between the demand for its product and the price charged. When the price of the product is $3 per unit, the weekly quantity demand was 500 units. When the price was raised to $4, the weekly quantity demanded was 300 units. Assume that weekly quantity is a function of price. Number 1. What are the independent and dependent variables? Number 2. Find the equation of the linear function that models this situation. Number 3. Using this equation, predict the weekly quantity demanded when the price is $2. Number 4. Using this equation, predict the price when the weekly quantity demanded is 100. Solution. Number 1. Assume that the weekly quantity is a function of price. That tells us what is the independent and what's the dependent variables. A function of price means price is the independent variable and weekly quantity is the dependent. So we would say weekly quantity depends upon price. So price is the independent variable and weekly quantity is the dependent variable. As an order pair, price, which is measured in dollars, comma, weekly quantity. Number 2, we are given 2 points from this problem: $3 and 500 units, $4 and 300 units. So our first step is to find the slope between these 2 points. So the difference of the y's becomes negative 200. The difference of the x's becomes 1. So we can say our slope is a negative 200. To find b, we use the form y equals mx plus b. We substitute our slope in for m, and I'm using the point 3,500, so y is 500, x is 3. We multiply, we get 500 equals negative 600 plus b. Adding 600 to both sides, we see that b is 1100. So the equation of the line becomes y equals negative 200x plus 1100. If we use the variables from this situation, we see that quantity equals negative 200 times price plus 1100. Using function notation, we could write it as Q of P equals negative 200 times P plus 1100. Number 3, we have our equation. We want to predict the quantity demanded when the price is 2. So Q of 2 would equal negative 200 times 2 plus 1100, which becomes negative 400 plus 1100, which gives us 700. So when the price is $2, the weekly quantity demanded is 700. Number 4, we're going to predict the price when the weekly quantity demanded is 100. So that means Q of P is 100. We want to solve for P. So we subtract 1100 to both sides. We're left with negative 1000 equals negative 200 times P. Divide by negative 200. Negative divided by negative is positive. And we have that the price is $5. So as the price increases, the quantity demanded decreases. And because we know the slope is negative 200, we could say as the price increases by $1, the weekly quantity demanded decreases by 200 units. Example 5. As a diver descends into the ocean, the pressure increases linearly with the depth, i.e., pressure is a linear function of depth. At the surface, a depth of 0 feet, the pressure is 15 pounds per square inch, psi. At a depth of 33 feet, the pressure is 30 psi. Number 1. What are the independent and dependent variables? Pressure is a linear function of depth. That tells us depth is the independent variable and pressure is the dependent. If we write this as an order pair, depth, which is measured in feet, comma, pressure, which is measured in psi. Number 2, we are given 2 points, 0 feet, 15 psi, 33 feet, 30 psi. Finding the slope between these two gives us 15 over 33, which reduces to 5 over 11. So we could say as the depth increases by 11 feet, the pressure increases by 5 psi. Now we could also divide those. 5 divided by 11 is approximately 0.45. And if we were to interpret the slope here, we would say as the depth increases by 1 foot, the pressure increases by 0.45 psi. To find the equation of the line, we're going to use our y equals mx plus b form. We know the slope is 5/11. And to find b, we can use the fact that when the depth is 0, the pressure was 15 psi. That means that b is 15. To put x and y in terms of the problem, we have pressure equals 5/11 times the depth plus 15, which we could write that as P equals 5/11 times D plus 15. And in function notation, we could write it P of D equals 5/11 times D plus 15. Thanks for watching.